So let's just recap. Okay, let's recap what we talked about yesterday. Um, so the very first thing that we talked about were sequences, right? Yes.
Have you recorded?
I am recording. Thank you very much for the reminder. Um, we started by talking about sequences, right? What did we say a sequence is? A
Series of numbers and patterns.
but not a series. Don't use that word. It's a set. Okay, how about a set of numbers created using some sort of term generator, right? Okay, and the domain of any sort of sequence is just the term number. And we use n to denote term number, and we usually start at 1. And then a sub n is either the term value or the term, what do we call it? The term generator, right? The term generator, okay? The formula, in other words, that you are given that helps you come up with the term values, okay? So, and then we said that a series is a what? Sum of the sequence, right? It is the sum of the sequence. And we said that what we are ultimately interested in is convergence or divergence of the sequence or series, okay? How do we know if a sequence converges?
We know
If it has an actual limit.
If while doing the limit, I get a finite number, right? I do a limit as n goes to infinity, and if I get a finite number, then that is, then the sequence not only converges, but it converges to that number, right? To that value, okay? So that's when we talked about a sequence. Then we went and we were interested in either convergence or divergence of a series. And a series is a sum of a sequence, right? So we said that the easiest thing to start with is something we call the nth term test, where we actually take the series and we write it, we take that term generator for the series and we write it in a limit problem. The limit as n goes toward infinity, right? If that limit goes to some number, then what do I automatically get to say? That the series diverges, right? Okay, and then we talked about why that would be. If I do a limit as n goes to infinity of a sequence and I get 1/2, okay, as my value, or let's say 2/3, because that's the last example that we did in class, right? We said we did this problem, we rewrote it as a limit, and we found that that limit was 2/3. Well, 2/3 is the value that the sequence converges to, right? Okay, so the sequence would, if the sequence converges to 2/3, but this is a series, right? The sum makes it a series. Then essentially what you're doing is you are continually adding 2/3 to the previous sum, right? Well, that's going to increase without bound. Therefore, we say that the series diverges. And we were able to come up with this idea of an nth term test. If you do a limit as n goes to infinity for the term generator in a series, and it goes to any value other than 0, we would say that the series diverged. And then we touched briefly on what happens if you get 0. And do you remember what we said? We don't have enough information, right? It might converge, it might not converge. And we will learn to determine that using all these different tests that we're going to learn from now to section 9.6, okay? So we generally always start with the nth term test first, because if I get a value other than 0, boom, I'm done. I get to say it diverges. If I get 0, then it's kind of back to that limit thing. When we got 0 over 0, we had to do more work. Same thing. If you're finding the limit as n goes to infinity of a series and you get 0, you're going to have to do some more work. You're going to have to look at what kind of problem it is, and you're going to have to apply the correct test. And remember we said, did we talk about the reasoning for that in here? Okay, so if you think about it, you don't have to write this part down, but remember when we did this problem, we did the area from 1 to infinity of 1 over x. And then we did the limit from 1 to infinity of 1 over x squared dx. What did we say about this one? It diverged, right? What did we say about this one? It converged. But what is the limit as x goes to infinity for both of these? 0, right? As x goes toward infinity, the limit of these is 0. But what happens is you don't know if it gets to 0 quickly enough so that it converges. Okay, so it's this same sort of idea here. Even though the limit may produce a value of 0, you don't know if it is approaching 0 quickly enough for the entire series to converge. Okay, does that make sense? All right, this is where we stopped in the notes. Am I correct with you guys? Okay, so let's do one more example. We'll summarize the nth term test and we'll continue. So the next example would have been this one, the sum from n equals 1 to infinity of n factorial over 2n factorial plus 1. And again, the directions are just determine the convergence or divergence of that series. And please note, the question came up, is that 2n and the whole thing factorial or 2 times n factorial? That is 2 times n factorial. If it was the other one, there would have to be parentheses there.
Around the 2n.
Around the 2n, and then you would have the factorial sign. Yes, ma'am. Correct. So the first thing I'm going to do is rewrite this thing as a limit problem. I've got the limit as n goes to infinity of n factorial over 2 times n factorial plus 1. And what Kevin just mentioned is that as n goes toward infinity, this plus 1 becomes insignificant, right? So then what happens? The n factorials, they cancel out, right? That's going to be the same thing. And what do you end up with? 1/2. So what do I automatically get to say about that series? It diverges.
So whenever a series diverges, a sequence has to converge. The sequence.
Yeah, I guess that's, well, I don't know that it would have to because it could go to infinity and it would, okay. But I just think a good way to think about it is this is what the sequence converges to, right? So with the series, you would basically be taking your previous sum and adding 1/2 to it for every other partial sum. So that sum's going to grow without bound. Okay. Were there any other questions I can help with? No? We're good? Okay, so beware. Beware. The nth term test cannot be used to show what? Convergence. And we just talked about why, right? We put up the those 2 area examples. The nth term test cannot be used to show convergence. Only used to show divergence. If the limit produces 0, we do not have enough information. and must use another test to determine convergence, divergence. I feel like we're talking about the movie.
No.
Okay. If the limit produces value of 0, we don't have enough information and must use another test to determine convergence or divergence. Did you get it, Josh? I know you can't see. Am I talking slow enough?
Yeah.
Am I good? Okay. So one more time, nth term test cannot be used to show convergence. It's only used to show divergence. If the limit produces a value of 0, we don't have enough information and must use another test to determine that convergence and divergence. Okay, so let's move into another type of series. And from the title of the notes, you know, the next type we're going to talk about is the geometric series.
Is this still part of 9.2?
Yeah, it's still 9.2. All this is 9.1, 9.2. We're just going to finish it up today. We won't start 9.3 until tomorrow.
What should I do?
Okay, so given the series, the sum from n equals 1 to infinity of 3 over 2 to the n power. Given the series, the sum from n equals 1 to infinity of 3 over 2 to the n power. Find the first 10 terms of the sequence of partial sums. Okay, so you had a couple homework problems like this. I thankfully only asked you to find 5 terms, not 10, but this one you need a few more to kind of see it. So given the series, the sum from n equals 1 to infinity of 3 over 2 to the n power, find the first 10 terms of the sequence of partial sums. Carson, were you talking about this last test that we took?
Yeah.
And I didn't realize that when you asked, and I can't hand that one out yet because not everyone's taken it. And I'm
Alright.
very sorry, I didn't realize till after you left.
No, it's
If you want to
alright.
stay in here for lunch, you can.
No.
Okay, sorry. Forgive me, please. Okay. All right, so my first sum, and we'll call this S sub 1, is just equal to what? 3 halves, right? It's just that the first term that's produced when you plug in 1 for n. And I'm going to put the decimal equivalent here, it's 1.5. So S sub 2 will be equal to 3 halves plus 3/4, right? We're doing a sequence of partial sums, so you have to take the previous sum and add the next term to it. So S sub 2 is created by taking S sub 1 and adding the next term, the term you get when you plug in 2. And that is 2.25.
See how Derek's is low?
Yeah.
I noticed it. Like
So your third partial sum would be the 3 halves plus the 3/4 plus 3/8. And that's 2.625. And I'm not going to make you, I'll give you some terms here because this is
Oh, I did it wrong.
pretty boring stuff. Yeah, and I think what happened is after people saw this, because I didn't talk about it more yesterday, they missed it. The set of directions didn't make sense to them. Okay, so S sub 4, you would take this value and you would add to it 3 over 2 to the right? 2 to the 4th power. And I'm here to tell you that you'll get 2.8125. S of 5, you would take this value, and to it you would add 3 over 2 to the 5th, and you'll get this. And we're going to skip some values, and we're going to go on, head down here to the 10th partial sum. S sub 10. But you understand what you have to do to get to S sub 10, right?
Yes.
Take your previous value and add the next one. Okay, so when you get to S sub 10, you're going to get 2.997.
There's approaching it.
And it would appear that the sum of the sequence is approaching what, if you had to take a guess? 3, right? And you could do more values and more values, and you're going to get closer and closer to 3. So this series, right, a series is the sum of a sequence. So if I sum together the first 10 terms in the sequence, I'm getting this number right here. It appears that this is approaching 3. So this series that we're working with is called a geometric series. What makes it geometric? Do you remember?
It's the, what's it called, the power.
Well, I need a little bit more information, but
Sorry, it's raised to the nth power in
what is?
the number.
Which number?
A sub n. The formula you're given has the variant that's raised to a certain power.
Okay. Yeah, I mean, I know where you're headed. Okay.
I don't know how else to explain it.
That's okay. I'll help you out. So this particular type of series is called a geometric series. And a geometric series is a series created by multiplying by a, do you remember from pre-cal what you called it? Common ratio. What is the common ratio in, well, here, we'll rewrite it and you'll be able to see it. Okay, so here's the series I'm dealing with, right? It was this. I can rewrite this so that it matches that definition a little bit nicer. So this is 3 times that, right? This can be rewritten as 3 times 1 over 2 to the n. And how can 1 over 2 to the n be rewritten? How about that?
Yeah.
Right? 1/2 to the n. So what's your common ratio? The 1/2, right? It's 1/2 that you're multiplying by every single time to get the next term. So your first term was 3/2. Your second term was 3/4. Your third term was 3/8, and so on. Okay? So now I will tell you, AP likes to write their geometric series like this, and you've got to be able to recognize that I can rewrite it like this so that I can see that common ratio R. Okay? But hopefully you see that. Okay, so do you remember me telling you the other day that there was only one type of series that you would be able to calculate its sum? Like actually find out what the sum of the series is. The only one that you will be able to do that for is geometric. And you learned how to do this in pre-cal. Somebody in third block was able to recall the formula. I don't know if any of you are able to.
Who was it?
Was it red?
I know, James.
Oh, of course it's James. James is crazy.
Okay, sum of a geometric series. S is equal to a sub 1
minus R.
over 1 minus r. Does it at least look familiar?
Oh, yeah.
The sum is equal to a sub 1 over 1 minus r, where, what was a sub 1? I heard somebody say this a while ago.
First.
The first term. A sub 1 is the first term. Here, I'll put in the series. First term in the series. And R is the what?
Rate.
The common ratio.
Would it be the first term in like the sequence whenever you plug in one?
Yeah, I put there the first term in the series.
Coach Sanders, can you have some batteries?
Yes. Okay, so now, remember, it's always convergence and divergence that we're interested in, right? So talk to me about how I'm going to know if the geometric series converges or diverges.
R equals, or R equals 1. It's either greater than 1 or less.
Okay, I'm hearing greater than 1, less than 1. Think about it.
It has to be less than 1.
Why would it have to be less than 1, Natalie?
Because then when you have the r raised to the n, then it means it's going to be 1 over whatever it is. If it's greater than 1, that's going to go into infinity because you're just going to keep getting bigger and bigger and bigger. And if r is less than 1, then it's going to be some number and the denominator is going to keep increasing. So it's going to go to 0.
Okay, so if your common ratio is less than 1, say it's a half, you're going to keep cutting everything in half, right? So you're going to get this value. The next value is going to be that one cut in half. The value after that is going to be the previous one cut in half, right? And as long as that ratio is less than 1, then you're going to eventually get to 0, okay? And that's going to allow you to figure out a sum. But like she mentioned, if r is bigger than 1, you're going to multiply by a number that's bigger than 1 every single time. You're going to keep adding that together. Well, that number is just going to grow infinitely large. So a geometric series is only going to converge if its ratio is less than 1. So, and it is absolute value because these values can be negative. So if the absolute value of r is less than 1, the geometric series does what again? Converges. And if the absolute value of r is greater than 1, the geometric series diverges. Yeah, if it's equal to 1. If it was 1, it probably wouldn't. Like you wouldn't see that in a geometric because nothing would be happening. So let's find the sum of the series that we were just dealing with. The series from n equals 1 to infinity of 3 over 2 to the n power.
So is that like saying to find the sum of the sum?
Yeah, you're finding the answer to that infinite sum. Okay? And again, a geometric series is the only series that we are going to be able to calculate the actual sum. If you were to add together an infinite number of terms, a geometric is the only type of series we could actually figure out the answer. Okay, for all of the other types of series, you're only going to be able to determine whether they converge or diverge. Yes, Michael?
What makes it different than doing like the nth term test? Like why does the series not converge?
Well, remember, if you were to do the nth term test on this particular one, you would get 0, right? Well, when I do the nth term test and I get 0 as my answer, I know nothing about the convergence or divergence of that series. So if that's what you started with, and that's a great starting point all the time, you see that the limit goes to 0, so then you ask yourself, right now the only other test you have is geometric. So right now you say, oh, okay, is it geometric? And then if it is geometric, is r less than 1? And if r is less than 1, then I get to say that it converges, if the absolute value of it is. Does that help? Okay. All right, so find the sum of this series. So, and again, you may want to rewrite this so that you can more easily see that common ratio, or r. Yes, Mary?
Is this like finding an integral? Because if you look at the graph of 3 over 2 to the n, are you finding the area underneath that graph? Are you adding all those values together?
Yes. Yes.
Wow.
Let me see your picture of it. Will you just hold it up for me? Yep.
You add all those y values together, you're finding
From
that
1 to
integral.
infinity, right. It's like an improper integral.
Mhm.
Yep. It's exactly what you're doing.
Putting all those y values together at every single point. So could
Mhm.
you do this using an integral?
But instead,
It would be an improper interval.
Yeah, that's okay though, because you just have to rewrite the limits of an. You have to know how to integrate a to the n power, which I'm only concerned because we're on a little bit shortened
Yeah,
a period. Can I finish with this and then that? I love your question and I love that you're thinking about it. And the integral test is a test that we will use to difference and divergence. We just wouldn't be able to say what the answer is.
Because it's to infinity?
Hmm.
Okay.
Well, not that reason, but something else.
Okay.
I'll
We
have
can
to
just do
come
this
back and
as-
address it. Let me finish this, Natalie, because you're going where she's going and I need to get through this really quickly. Okay, so a sub 1 is what? 3 halves. And what is r?
1/2.
1/2. And the formula is a sub 1, which is
3/2.
3 halves, divided by 1 minus r, which is a half. So we get 3 halves divided by a half, which is 3 halves, times 2 over 1, which is 3. And that's exactly what we said that it appeared that it was summing to, right? When I did all those partial sums, when I added a term each time, it appeared that it was going to 3, and in fact, it does go to 3.
So will it ever reach 3 before infinity?
The 2.99999.
Well, at some point, it will, yes. Okay, so now you should be able to complete your worksheet. Now you should be able to complete 9192. If you found by going through this that you might have done something incorrectly on 9192, you can go back and fix that. Or if you didn't know how to do something, hopefully you do now. For this one, they are not, but I can probably put a picture up in just a minute, okay? What time, 1:53? Okay, yeah. So we're a little bit ahead of the other class. So you guys can go ahead and just work on the homework. So that's worksheet 9.1, 9.2.
Could you go over number 9 for on 1.1 to a sequence
Yes.
of